All right, team, we're in the home stretch when it comes to talking about piloting and the processes of piloting. Now that we've talked about all the publications that we use to prepare ourselves for piloting, we're going to discuss the piloting routine as you conduct it during a restricted waters transit. So when you make the transition to piloting, what we're talking about here is moving from, for example, open ocean to entering a port. So we're transitioning over into that routine of piloting, stationing the piloting team or the navigation team. In most cases, once we begin in a modified navigation detail, for example, and then we're going to transition to the full sea and anchor detail as we get closer to restricted waters. And as listed here, of course, the CO and the SWO will rely on your recommendation for when to station the detail. That's information that as you get closer to entering port, for example, you need to be in communication with the CO, the SWO, or whoever's developing the plan of the day to make sure that everybody knows what time you need to be stationing the details so that you can plan the day appropriately. And then, of course, when you approach landfall, the navigation team is going to take advantage of the accessibility of navigational aids. So out in the open ocean, we don't have a lot of visual and radar nav aids to correlate our GPS position, but once we get closer to land, we are able to check that. And as emphasized in earlier lectures, you really want to make sure that as soon as you are able to take some kind of fix to confirm your GPS position as you approach land, highly recommend that you do so to make sure that you're starting off on the right foot. You don't want to realize that you've got a discrepancy late in the detail. You want to find out as early as possible. And then finally, a determination of when to decrease the fix interval. Of course, the NavDorm provides these overarching guidelines as to when is the right time to adjust the fix interval. However, this is always something that you can be more restrictive of on your ship and should be a situationally dependent thing. For example, while the NavDorm requires you to be in 3-minute fix intervals in restricted waters, you can always decrease that fix interval if you need to. So let's discuss the types of fixes. A GPS fix, of course, you're getting latitude and longitude by your installed GPS system, your GPS 1 or 2, or your Dagger if that's what you're using. And that can just be directly plotted onto a chart or just being displayed on your VMS. And then, of course, the fix by bearings, which is a common intersection of 3 or more visual LOPs. Then fix by ranges, a radar fix is the most common version of these, but you have a few other options here using a statometer or sextant angle as well as sonar. Certainly those are less common, but they do apply to this type of fix, which is an intersection of 2 to 3 or more range arcs. And then a composite fix is simply going to combine these various LOPs. For example, combining several visual LOPs with perhaps a range from the radar to develop a fixed position. So for fixed type and fixed interval, of course, we discussed both of those are going to be situationally dependent. As the nav or ANAV, when you're standing nav eval during a detail, it will be up to you to sort of take a look at the information that your radar nav team or your quartermaster team, your visual team, what kind of information they're getting and what's going to give you the best possible fix. And then, of course, as we mentioned earlier, what fixed interval is most appropriate given what you have going on around you. Something to note is that in some cases, things aren't looking good for whatever reason, and you get a no fix. A no fix situation basically means that whatever you're using to try and attempt to fix the ship's position is not working out, right? So maybe you have poor radar information and things aren't cutting for that reason, Maybe somebody is looking at the wrong nav aid. Whatever reason it might be, you have a no fix situation. When that happens, you need to announce it loudly on the bridge, or if in the case of the piloting officer down in combat, if that's the way your ship is configured, that person should be announcing it in CIC, as well as notifying you on the bridge. And of course, as soon as we encounter a no fix situation, we want to be making sure that we can determine the ship's position as quickly as possible. So if we have a no fix situation, we should immediately attempt to lay another fix. And then even when we successfully do that, we want to lay a second fix 1 minute later, right? We don't want to wait another 3 minutes because we just want to confirm that that fix that we do get after a no fix situation is accurate. Now I want you to think about, when it comes to taking visual LOPs, what order we want to be taking those in. And that means in relation to where the visual nav aids are to the ship. Think about that and think about why it makes sense to take one of those before the other. And then same thing goes for radar or range LOPs. What order do we want to collect them in and why? So just pause the video, think about that for a second, develop an answer before we go over it. Okay, so you've thought about that. Hopefully you've jotted that down, whatever you think makes the most sense, and let's just cover what that would be. For visual fixes, we want to take them in the following order. We want to take a visual LOP starting from a nav aid on the beam, if we have one, followed by the bow and the stern. And why is that? Well, what we want to do is we're, of course, trying to get the most accurate fix that we can. So we want those LOPs to be as accurate as possible. So we take the one from the beam first because if you think about it, if we are driving past an object on our beam, that bearing is going to be changing more rapidly than something either on the bow or the stern. And that's just because of the relative position of that nav aid. So if we take the beam LOP first, we're going to get the most accurate type of fix, because if we wait and take that beam LOP last, for example, it's going to be a good bit different than it would be if we had taken it even 30 seconds earlier, depending on the speed of your vessel. For radar LOPs, something slightly different applies. In this case, we want to take radar LOPs starting with the ones on the bow, followed by the stern, and then the beam. And it's for the same overarching reason as the visual LOPs, in the sense that when we're taking a radar range to a radar nav aid, the ones that are on our bow and our stern are going to change more quickly than the ones on our beam. Even though the bearing to a nav aid on our beam is going to change rapidly as we drive past it, the actual distance between us and that nav aid will not change a lot. So that beam radar range is not going to be as helpful to us as something that is going to be on our bow and our stern. And if we want to accurately fix the ship's position, we want to capture those changes as they happen. So for radar LOPs in that case, we want to do bow, stern, beam. So just remember that those are different depending on whether we're talking about visual LOPs and radar LOPs, and just think about whichever one we expect to change the fastest, that is the one we want to collect first. And of course, in either case, whether we're doing a visual or radar fix, we want to widely space those LOPs. We want to ensure that our nav aids are appropriately spaced so that they give us a good cut. And we'll see what that looks like here in upcoming slides. If we have two nav aids at nearly the same angle, they're going to not provide great LOPs. Either the bearings are going to be very similar and they're not going to provide us a good cut, or the ranges will also be similar and a similar situation happens.